Hi, I'm Dr. Alexander NGENZI from University of Rwanda College of Science and Technology, Department of Computer and Software Engineering. We have seen the graphical example. Among the methods that we use, graphical, DFT and IDFT. And in this case, we are going to continue from the matrix example method, where we are going to discuss about how matrix format using using the folded sequence can look like. So we are going to continue with our examples using the matrix method, so that it will give you insight of how these formulas can be obtained. Yeah, okay. So to begin with, we are going to do another method. We have seen the graphical method, but now we are going to use structural convolution method 2. Method 2 is going to be structural convolution using matrices. So this is what we are going to discuss. So remember, on our matrices form, for example, if we have the value of matrix, for example, in this format, you have big X of 0, remember. Okay, in this case, we will have denomination 2, X of 2, all over 1, X of 2, 2, then X of 2, 3. And in this case, we are using the X2 to compute, for example, X of 2, 3, then X of 2, we are putting the other values of ours at any particular point, X of 2, then X of 2 at 1, then X of 2 at 2, given the number 2. And also we have X of 2, 2, X of 2, 3, X of 2, 0. All these values, you know where they are coming from. It is from the previous example. And here we have at X of 1. Okay. And then you put X of 2, 1. X of 2, 2, then X of 2, 3, then X of 2, 0, in this case. So, and remember, these ones are multiplied by the other way around. So it's going to be multiplied by X of 0, which is equal to X of X1 at 0, X2 at 1. No, X1s. These are the X1. These, of course, these are the inputs. Remember, there are two signals at any point. So it's going to be like this. Remember, we have two signals. We have X of 2 and X of 1 in this case. So it is multiplied to get the output as the big X's, which is going to be the X of 3, that is big X of 0, then X of 3 at 1, yes, x of 3 at 2, then x of 3 at 3, this point. So this is the output that we are trying to look. So this is how the matrix of, okay, I'm sorry, this one could have gone there, but it is the same. It is this output that we are looking for. So we are trying to get this output and given these two signals. So this is a circular convolution using a matrix format, and we are still having, so you can supply any number given all these notations. So you can multiply any number depending to which point, you can supply the number according to which number at any particular point here, if it is x2 of what, so you put any number here. Suppose if here is 1, 2, 3. So now let us just have an example and supply according to these values, for example, and see how it is going to look like. So suppose here, for example, we supply the values in this case, which is 1, 4, 3, 2, as the first column, the x0 like that. Then you can have 2, 1, 4, 3. You can have also 3, 2, 1, 4. Or you can have 4, 3, 2, 1, multiplied by the x2. I mean the x1, of course. Remember, this is the x2 format. Now we are going to put the x1. So remember, the x1 was 2, 1, 2, 1 in this case. So you will end up getting this. You will end up getting the value. This one is going to be 14, 14, 16, 14, 16. And if you extend it, for example, the x3 of m, which was 3 of m, is going to be in this sequence, because we are just looking for folded sequence, in this case using the matrix method. Now we can get, this is 14, the 16, 14, and then 16. So this is the general answer that we have obtained from x of 3. 3m. Of course, this is what we have obtained using the matrix format, but also we have seen also how we can use the graphical method using the folded sequence. We also have to understand that it is also possible to use DFT as another method, DFT or IDFT. This one also can be also correct. So we have seen the graphical method. This is also a method that we have seen to obtain the convolution, the circular convolution. We have also seen the other one where we used the previous one, that where we used the matrix form method. So the DFT, we didn't want to go into details, because we have discussed much about these details, and we said it's all over the chapter 3 that we have been discussing all these issues. We used DFT and IDFT. So I wanted to let you know or understand the other methods that we can use, especially when we are using the structural convolution, which was our last subtopic that we discussed about the way how the signals can be brought together, in the folding sequence, in a symmetric value, the periodic way, and so on and so forth. So to that point, we have come to the end of our chapter 3, where we discussed, among others, where we saw some of the elements. Of course, we discussed about the signals and their tools, analysis of signals and their tools. We also discussed about the discrete Fourier transform on its own, the inverse, its inverse. We also discussed about their properties, the examples, the calculations of some examples, where we saw some of the examples related to DFT. We also discussed about the structural value, where we had the big Wn equals to e power something. You remember all those terms. We also discussed about the DFT using matrix. Well, this is what we have covered today. We discussed about the methods, how you can obtain the DFT, having the graphical, the DFT itself, and the IDFT. We also discussed about the matrix format. So to obtain the convolution sum, we have seen the way how you can obtain signals using all those methods. So I hope we have understood the summary of our chapter. Maybe you will go back and see all those that you have not mastered. Then you try to practice and just get what was it about. So please remember to subscribe, share, and like, and put some comments. Your comments are very, very useful to me so that I can improve on my online teaching. Thank you very much for today.